I'm the global lead for energy storage for Morgan Advanced Materials, and that encompasses all the work we do on batteries, lithium-ion and flow batteries, and also fuel cells, and anything related to electric vehicles. Proudest moments in my career, there's been 3 materials where I've either led the team or at least been part of a team, a significant part of a team where we've created things which are globally best in class. The first one being graphite being used to make synthetic diamonds for oil and gas drilling, interesting in the energy space. Second one is ablative carbon for space vehicle propulsion. And the third is anode graphite for lithium-ion batteries used in power tool applications. So it's great to be part of teams when you create something which legitimately is #1 in the world. In terms of Morgan, our strategy is to be a net zero CO2 business by 2050. By 2030, we're targeting a 50% reduction in emissions. The two of the different categories of emissions, both ones related to what we're purchasing and what we're generating. So they have different codes. The scope 1, scope 2, they're officially called. We're also targeting a 30% reduction in water by 2030. So they're very important. On a personal level, I also try to do my part. I know that's not. I'm not going to be a net zero business, but my wife and I share one car, which is somewhat unusual in the United States, and we're pretty big on recycling. And I'm always proud when I see we get a monthly report on our house energy usage, and I think we're usually top of the neighbourhood of a couple of thousand houses. So we take that very seriously as individuals. Solid state is a fascinating area, which, as you know, I'm heavily involved in. The biggest area people have focused on over the last few years really has been the conductivity of the electrolyte, the lithium-ion conductivity of the electrolyte, trying to make it as conductive as the non-aqueous electrolytes which are used in standard lithium-ion batteries. That problem, to a large extent, has been solved. Where we're left now is a real economic challenge. So saying how will it be solved, I don't think it's a one-size-fits-all type answer. There are different types of electrolyte. They each have some technical challenges, but they all have economic challenges. And when you start looking at the cost of a solid-state battery versus a standard lithium-ion battery, you are at least 1, if not 2 orders of magnitude too high at the moment. So somehow that has to be solved. One way is to use current equipment, but that's not necessarily easy when you're using different materials. Another way is to find standard processes where that equipment is available. As just an overall comment on batteries, when you're looking at how things are going, you're seeing a very heavy cost down. You're seeing massive ramp up worldwide in terms of production, and there are going to be a lot of challenges in the next few years. People typically talk about material shortages, but I think we're going to see challenges with a lack of experienced people, because you simply cannot grow at the speed it's growing without realizing there just aren't enough people with experience to actually be able to help grow at the speed the industry's growing. And then equipment as well. I think we're going to see equipment pinches where too many companies are going to be looking for the same items of equipment, and you'll simply see very long lead times on standard equipment, tape casting type equipment, or mills, and anything within the process chain. So you're going to see equipment and people challenges, as well as materials issues. And with solid state's going to face all those as well, and that's also going to face it at the same time as the current industry is growing. So it's a fascinating time because there's just so many areas to address. Cold sintering, I'm always going to say cold sintering until it goes one way or the other. So the work really led by Professor Randall out of Penn State to create dense ceramics at temperatures below 300 degrees technically is fascinating. Now, as to whether that's going to be a huge commercial rollout, I'm still not sure. It does give opportunities to do different things with materials. For example, putting sensors within blocks of materials where you couldn't previously do that because of the high temperatures. But that to me is very interesting work. 3D printing is still there. allowing us to make structures which we couldn't previously make. And then I think in the world of nanotechnology, some of the work in ALD, which I think you have somebody from Forge Nano on the advisory board of this conference. ALD is going to have a big impact, and that's going to have a big impact in solid state. I didn't obviously talk about all the different issues with solid state, but interfaces are a major part of challenges, and having a nano coating is going to make a big difference in solid state batteries as well as standard batteries, because coatings and nanomaterials are going to make a big difference. So that's in terms of material technologies. But then I'd also say, computational studies, materials design, that will make a big difference in the industry. Some of the work, I think of the work of Professor Kurt Rolo out of Duke as leading the way in that space. And others may argue there's many people involved in it, but he is certainly one of the leaders. And at the materials level, graphene and carbon nanotubes, those are very exciting. How far those are going to get, I don't know. A lot of money has gone into graphene. It always seems to be waiting for the big application, and there are big applications, and certainly there are companies that will tell you they've now got the big application. For example, maybe in tires or in antioxidation coatings. But yeah, graphene carbon nanotubes, would love to see where they're going to go in the next few years. So the most obvious answers would be, well, we had the global financial crisis about 10 years ago, which definitely created some challenges for many people, many industries. As Morgan, we did reasonably well because we're quite well positioned geographically and in terms of a plethora of markets in which we're engaged, which helps us in situations like that. Got COVID. I mean, that's obviously on people's minds for the last couple of years, which has caused issues, not just the health of people, but also supply chain issues, which is related to various parts of supply chain shutting down for certain periods. And we're certainly seeing that within automotive, with some of the chip issues, semiconductor issues at the moment, which is making quite a difference, even touching on electric vehicles at the moment. Personally, though, I think the biggest issue, which I'm going to say hasn't been addressed, it's being addressed, but is geopolitical. And that's certainly been more prevalent because of COVID. People have noticed just how dominant China is becoming in the world of science and materials, and I think the West is going to have a lot more challenges than it realizes. China has made such phenomenal progress, and the quality of Chinese scientists is so great now. So in the world of innovation, previously the West had this sort of view that it could innovate its way out of trouble. But now you start looking at patent filings. China is, I think, as of 2019, is taken the lead in terms of patent filings as a potential metric of innovation. It's about a third more filings. They have about a third more filings than the United States, and that United States is about 2x versus third place. I had the privilege of living in China for a few years, and I'm afraid I went in as a somewhat naive Westerner, thinking we're so smart, and then you realise China has moved so far, and factories I've seen in China built in recent years have been state of the art, better than any ones I've seen in the West. I think the West, again, the battery industry in which I'm engaged, has this idea that it can build a factory and be competitive, and it's going to have its eyes opened wide very shortly. So the geopolitical challenge as to how things are going to move forward, and I'm just thinking China versus non-China is going to be a big tussle. It's something which we have to address. Do we set up businesses in China? Do we accept we'll do downstream processing? There's so many things involved with it, and I think your question was, how have we solved it? How have we come through it? We haven't come through it. I'm not necessarily saying it's bad. I mean, it's just a situation, but it is getting more and more intense as years move forward. China is doing a phenomenal job in science, and we have to think our way through it, Western companies, as to how we position ourselves in that context. Well, advanced materials, that it's a subject of passion for me anyway. So having a conference based around it is great. I mentioned coatings, so all the technologies related to coatings, not just from Forge Nano, other companies, but it's something I need to get up to speed with or keep up to speed with to see if there are any new developments. So opportunities to talk to people. Happy to to give a presentation at the show, but really, this is one of the first shows that's going to be in person since COVID started. There is so much lost. I mean, kudos to conference people like yourselves setting up virtual conferences, and really have done a very nice job in the last year and a half. But there's so much lost if you don't meet people in person. The discussions around the metaphorical coffee pot or the actual coffee pot, the dinners, the corridor conversations, you learn all via Zoom and Teams. You learn what the official positions are of companies, but you don't learn what's really going on, which the real technology is making a difference. And that in-person experience, you cannot understate, you can't overstate the importance of the in-person contact. I think if I was going to give one piece of advice, it would be really think about market pull versus technology push. As a person, I tend to be quite enthusiastic very easily about many things. And I think I would say I've been guilty of many times I'm excited about a technology or about a material, about an idea, and then I spend my time trying to sell people that this is a great thing in which they should allow me to work. Really, it's better going from the other direction. So going from the market pull direction, learning where the challenges are, where you can then innovate to solve those challenges, to solve any problems in an industry. And then you have customers at the end of a development. Because I think, several times in my career, I've come up with something which I think is show-stoppingly different, but it doesn't necessarily mean it translates into revenue. And we as a business, as Morgan, we are so much smarter strategically than we were in making sure that we have not necessarily absolutely defined every customer we'll have lined up before we start doing technical work, but we certainly have a very good idea about how we're going to position ourselves in a market and which would be our key target customers before we start putting any significant resources into development. So I think that I would not only give that advice to myself, but I would give that advice to others, in our company and other companies, saying, look to solve problems. Don't look to create something and hope there's a problem to solve.